Hi, in the last session, we talked about VHDL functions. We learned how to use them and where to use them in VHDL design. Now, let's talk about VHDL procedures. Procedures in VHDL are quite similar to the functions, but with a small difference. A procedure does not return any value, but a function must return some value to the output. Function parameters are always input. However, procedure parameters can be input or output, or even it can be in-out. And that allows procedures to have more flexibility in processing data in and out from your procedure. Input parameters passes the values into a procedure, and output parameter passes the value out from the procedure. Also, there can be multiple output parameters with VHDL procedures, which is not allowed with the functions. Inout parameters allows you to pass the value as an input into a procedure, then it can modify based on the project needs, and then it can pass out to the output. So it works like that, and that make procedures versatile for many operations. Let's understand this concept with a simple example. Here is the basic syntax for a procedure. It starts with the procedure keyword followed by the procedure name. Then inside the bracket, we list all the parameters with their data types. And they also indicate if they are in, out, or in out. Now, before the begin keyword, we declare all the necessary variables and constant. Procedures do not keep their variable values between the execution, just like the VHDL function. They are reinitialized each time when the procedure is called. So, in short, procedures also do not store or keep any data after finishing its execution. Now, after the begin keyword, we can write our VHDL code to implement the desired functionality. And in the last, we end the procedure with the AND keyword as normal. So, overall syntax looks like this: procedure, procedure name. Now, list the parameters is, then give the constant or variable declaration in this section. Then write keyword begin, then write the procedure code here. Write your VHDL design or structure here in this section. Then in the last, terminate the procedure with the keyword and semicolon. Okay, now let's understand it with one simple example. So we are writing a procedure that implements a full adder circuit. In brief, a full adder is a combinational circuit that performs addition on the three single bit binary numbers. So a full adder generates a sum of three binary inputs, and it also generates a carry output as well. And you can use this full adder circuit to create a multi-bit adder by combining these full adder elements multiple times. So let's focus on the 1-bit version first. So we have these three inputs labeled as A, B, and C in. And we have two outputs, sum S and carry. The sum S is the result of the addition of these three binary inputs, and carry is high when at least two of the inputs are high. Now let's see how we can implement this circuit using a procedure. So here is a VHDL code for this procedure. Procedure full adder in the bracket signal A, B, C in colon in std underscore logic semicolon signal sum carry colon out std underscore logic bracket closed is. Now begin. Sum gets the value of A XOR B XOR C in semicolon. Carry gets the value of A and B or A and C in or B and C in and procedure semicolon. So these two statements are our full adder elements or full adder expression. So to implement this simple full adder circuit in the VHDL procedure, we start by declaring the procedure name. Here we gave it a name as full adder. Next, we declare all the necessary inputs and outputs and parameters for this. For our circuit, we have three std logic inputs, A and B and C in. We also have two STD logic outputs for sum and carry. These are declared just like a port signal, but here they are called parameters for this procedure. Now, inside the procedure body, we assign the values to the sum and carry signals according to their circuit diagram. And we finish up the procedure with the AND statement. Now, to call this procedure in our VHDL code, we use the procedure name and provide the inputs and output parameters inside the parentheses. So, if you look at the code in the bottom section of this slide, here we are using procedure for our adding functionality. In this example, signal X, Y, and Z are the input signals, which are corresponding to the parameters A, B, and C in our procedure. The sum result is assigned to the signal sum, and carry output is assigned to the signal Cout. Okay, so that's it for today. Here is a quick recall of what we have learned. We covered that where to use procedures in VHDL and how to write your basic procedure. So you can use your procedure while implementing the frequently used algorithms in your designs. By using procedures and functions in your VHDL designs, you can significantly reduce your code size for your design requirements, especially when you have to reuse some set of your designs multiple times in your code. So you can call these subprograms as many times as they are needed in your project design, and that too with just a few lines of code. So this enhances your efficiency and also code readability. I highly recommend to use functions and procedures to create your reusable codes. These subprograms can be easily ported to other VHDL designs as well. So they can save your valuable time and efforts when writing and maintaining bigger VHDL codes. In the next session, we will be talking about packages and libraries in VHDL. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to our community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.